So let's rewind the clock. The year is 1993. The internet is barely a thing for most people, and smartphones are still, well, basically science fiction. But in the world of PC gaming, something massive just dropped. It was a game called Doom. This wasn't just another game, it was a phenomenon. For the first time, players were thrown into this incredibly fast, three-dimensional world filled with demons and chaos. The graphics were unlike anything anyone had seen before. You could move up, down, and all around in a way that felt shockingly real. It was dark, it was intense, and it pushed the computers of its time to their absolute limits, and sometimes, honestly, beyond. Doom became the new benchmark. It was the ultimate test for any personal computer. If your PC could run Doom smoothly, you had a seriously powerful machine. The game's 3D engine created a sense of depth and immersion that was completely new. Players weren't just controlling a character on a flat screen anymore, they felt like they were in the game, running through those shadowy corridors themselves. This new level of realism hooked an entire generation of gamers, but it also exposed a major bottleneck in technology. To make these virtual worlds even more detailed and believable, computers needed a whole new kind of power. The problem was that computers back then were generalists. They had a central processing unit, or CPU, which is like the main brain of the computer. This brain was designed to do everything, from running your word processor to calculating spreadsheets and, yes, trying to draw all the graphics for a game like Doom. But the CPU could only handle tasks one at a time, very quickly in a line. When a game demanded complex 3D environments, the CPU would struggle to keep up. This resulted in laggy, stuttering gameplay, which could totally ruin the experience. Gamers wanted more, but the hardware just wasn't there yet. This challenge set the stage for a revolution. The hunger for better gaming experiences was creating a massive demand for a new kind of technology. Gamers and developers alike dreamed of worlds with smoother animations, more realistic lighting, and more complex details. They wanted to break free from the choppy frame rates and pixelated graphics that defined the era. The desire wasn't just for a slightly better version of what they had, it was for a quantum leap forward. Someone needed to figure out how to give computers the specialized muscle they needed for the visual demands of the future, and that someone was paying very close attention. Enter Jensen Huang. Back in the early 90s, he was just like millions of others. A passionate gamer who was completely captivated by the potential of these new 3D worlds. He saw what games like Doom were trying to do and imagined something even better. He dreamed of a future where games weren't just collections of blocky pixels, but were photorealistic, immersive experiences that were almost indistinguishable from reality. He wanted smoother frame rates, more complex textures, and lighting that behaved just like it does in the real world. His frustration with the limits of current technology wasn't just a complaint, it became an obsession. Jensen understood the core problem better than most. The CPU, the computer's main brain, was a brilliant multitasker for general tasks. It was like a genius who could solve any single math problem you gave it, one after another, at incredible speed. But drawing a 3D game world isn't one big problem. It's thousands or even millions of tiny, simple problems that all need to be solved at the exact same time. Every single pixel on the screen needs its color and brightness calculated for every single frame. A CPU trying to do this was like that one genius trying to paint an entire mural by themselves, one brushstroke at a time. It was just too slow. This is where Jensen had his big idea. What if instead of one super smart brain doing everything, you had a separate chip with hundreds or even thousands of smaller, simpler brains? These brains wouldn't need to be geniuses. They would only need to be good at one thing, simple math, specifically the math needed for graphics. And crucially, they could all work at the same time. This concept is called parallel processing. It's like hiring an entire army of painters to work on that mural simultaneously. Each painter is only responsible for a small section, but together they can finish the entire masterpiece in a fraction of the time. With this powerful idea, Jensen Huang, along with his co-founders Chris Malachowski and Curtis Preem, started a company in 1993. They called it NVIDIA. Their mission was simple but incredibly ambitious, to build a specialized processor dedicated entirely to graphics. They believed that by offloading all the visual calculations from the CPU to this new chip, they could unlock a level of graphical performance that was previously unimaginable. They were betting everything on the idea that gaming wasn't just a niche hobby, but was the driving force that would push the boundaries of computing for everyone. They were building a solution for a problem that many people didn't even know existed yet. For years, NVIDIA worked on this vision, releasing graphics cards that got progressively better. But it was in 1999 that they truly changed the game forever. That year, they launched a product called the GeForce 256. This wasn't just another graphics card. NVIDIA marketed it as the world's first GPU, which stands for Graphics Processing Unit. They coined the term to make it clear that this was a completely new category of processor, distinct from the CPU. It was a brilliant marketing move, but it was also true. The GeForce 256 was the first chip that could handle the entire graphics pipeline on its own without relying on the CPU for help with key steps. So, what made the GPU so special? Its design. Unlike a CPU with a few very powerful cores, the GPU had a massive number of smaller, more efficient cores. Think of it like a highway. A CPU is like having a few lanes for super-fast race cars that can go anywhere. A GPU, on the other hand, is like having a highway with hundreds of lanes, all dedicated to moving a huge amount of traffic in the same direction. For graphics, this was the perfect architecture. It could process millions of polygons, the basic building blocks of 3D models, at the same time, resulting in incredibly smooth and detailed visuals that left older hardware in the dust. The impact on gaming was immediate and dramatic. With the power of the GPU, game developers were suddenly free to create worlds that were richer and more complex than ever before. Characters could have more detailed faces and animations. Environments could be filled with realistic lighting, shadows, and reflections. Water could ripple and splash realistically. The entire visual quality of gaming took a giant leap forward. Games like Quake 3 Arena and Unreal Tournament took full advantage of this new power, showcasing fluid motion and graphical fidelity that made gamers' jaws drop. The GPU wasn't just an upgrade, it was a revolution that redefined what a video game could look and feel like. Suddenly, the GPU became the single most important component in any gaming PC. The conversation shifted from how fast is your CPU to what GPU do you have? NVIDIA had successfully created and now dominated a brand new market. The GeForce 256 set a new standard and the competition had to scramble to catch up. This intense competition fueled a rapid cycle of innovation, with each new generation of GPUs bringing exponential gains in performance. The dream of photorealistic gaming was no longer a distant fantasy, it was becoming a tangible reality, all thanks to the specialized power of the GPU. For a long time, GPUs were seen as hardware for just one thing: making video games look awesome, and they were incredibly good at that. But a funny thing happened. Researchers and scientists in other fields started looking at the unique architecture of the GPU, that massive parallel processing power, and had a realization. They saw that many of their biggest challenges, just like graphics, were actually made up of millions of small, repetitive calculations that could be performed simultaneously. They began to wonder if this gaming chip could be repurposed to solve some of the world's most complex scientific problems. This is where the story gets really interesting. The GPU's ability to crunch huge amounts of data in parallel was a perfect match for the field of artificial intelligence, especially for a type of AI called deep learning. Training an AI model involves feeding it enormous data sets and having it perform countless calculations to learn patterns. A CPU would take weeks or even months to do this. A GPU could do it in a matter of days or even hours. Suddenly, the GPU went from being a graphics engine to being the engine of the AI revolution, powering everything from the voice assistants on our phones to the recommendation algorithms on Netflix and YouTube. The applications didn't stop there. Scientists started using GPUs to run complex simulations for things like weather forecasting, molecular modeling for drug discovery, and astrophysical calculations to understand the universe. The same hardware that was rendering dragons in a fantasy game was now being used to simulate how a new protein might fold, potentially leading to a cure for a disease. This massive computational power, originally developed for entertainment, was now accelerating scientific discovery at an unprecedented rate. It was a classic example of how a solution for one problem can unlock possibilities in dozens of other unrelated fields. This is the power of Jensen Huang's original vision. the GPU became a general-purpose parallel computer. As Jensen himself has said, we have to create the technology that will enable the scientists of the future to solve the grand challenges of our time. He saw that the architecture built for virtual worlds could be used to understand and improve the real one. From powering self-driving cars that need to process vast amounts of sensor data in real time to helping create the stunning special effects in Hollywood movies, the GPU has become one of the most transformative technologies of the 21st century. So when you look back, it's pretty wild to think about how it all started. It began with a simple desire, a wish shared by gamers everywhere in the early 1990s. We just want better, smoother, more immersive games. We wanted to get lost in virtual worlds without the jarring lag or blocky graphics. This seemingly small wish created a demand. That demand inspired Jensen Huang and his team at NVIDIA to rethink the fundamentals of how a computer works. They didn't just try to make the existing parts faster, they invented a whole new part. They created a specialized tool for a specialized job. The GPU was born from the world of gaming, but it didn't stay there. Its core design, the ability to do many things at once, turned out to be the key to unlocking the next era of computing. It's a perfect lesson in how innovation often comes from unexpected places. The technology that was designed to render imaginary demons in Doom or explore fantasy landscapes in EverQuest is now the same technology that's helping doctors diagnose diseases earlier, allowing scientists to model climate change with greater accuracy, and powering the artificial intelligence that is reshaping our entire world. The journey from a gamer's wish to a global technological revolution is a powerful reminder that progress is often driven by passion. Jensen Huang wasn't just a CEO, he was a gamer who wanted to build the future he wanted to play in. That authentic passion led to an invention that has had a far greater impact than he could have ever imagined at that diner where NVIDIA was first conceived. The GPU has become a fundamental pillar of modern technology, an essential engine for scientific discovery, artistic creation, and artificial intelligence. It has quietly become one of the most important inventions of our generation. So the next time you see a stunningly realistic scene in a video game, or ask your phone a question and get an instant answer from an AI, or hear about a breakthrough in scientific research, there's a good chance a GPU is working hard behind the scenes. It all traces back to that moment when a group of gamers looked at their pixelated screens and thought, we can do better. That simple, powerful idea didn't just change gaming, it ended up changing the world, proving that sometimes the quest for better entertainment can lead to incredible progress for all of humanity.